Welcome to my workshop on logarithms. Today we're going to discuss the rules of logs. So what is a logarithm anyway? Well, let's take a look at the inverse of logarithms, and that would be exponents. So if we have a base raised to an exponent or power, we will simply get an answer. So the inverse of that would be log base of the answer equals an exponent. So therefore a logarithm is an exponent. So here are our logarithm rules, and as you can see, there are quite a few of them. So we're going to go through these one by one, but I would suggest if you're studying logarithms and it's part of the course that you're in right now, such as college algebra or pre-calculus college algebra, I would suggest getting some study cards made up on your rules of logarithms and try to remember those rules. Okay. So our first rule will be log base a of 1 equals 0. So this is a question that says if we have a to what power do we get 1? Well, the answer to that, of course, is a to the power of 0 gives us 1. So any non-zero real number raised to the power 0 is going to equal 1. So if we have log base 2 of 1, our answer also is 0 because 2 to the 0 equals 1. Log base x of 1 equals, well, that equals 0 also because x to the 0 power also equals 1, given that, of course, that x is not 0. Now, when we have log base a of a equals 1, well, this is true because a to the first does indeed equal a. So, with our first example here, we're saying log base 3 of 3 equals what? Well, it equals 1 because 3 to the first power equals 3. Remember, the 1 is our power. Okay. So to what power must I raise 7 to make it equal 7? Well, I'm sure you guessed it. The answer, of course, is 1, because 7 to the first power equals 7. Now, if we have a base raised to the power log base a of some answer equals the answer. So, basically, we have an exponential canceling out the logarithmic. These are inverse functions. So 2 raised to the log base 2 of x simply equals x. And if we have 6 raised to the log base 6 of y, that's just going to equal y. Now, one of our most powerful properties of logarithms say that if our answer, or often called the argument, if the argument is being raised to a power, we can just simply bring that power out, and then log base a of a cancels itself out so that we would have m equal to m. Now, another way of looking at that would be to say, to what power must I raise 3 to make it equal 3 squared? Well, the answer, of course, is 2. Now here we have a little bit of a trick here for you, because when we don't write the base is supposed to be 10. So this is a question asking us, to what power must we raise 10 to make it equal 10 to the power of negative 2? Well, the answer, of course, is negative 2. Now when we see ln means log base e. It's shorthand for e, Euler's number. So e raised to what power gives me e to the fourth? Well, the answer, of course, is 4. Now, when we have log base a of a product, in this case we have the product of n times m, we can split these up with addition. Remember, your rules of exponents say that if you multiply like bases, you're going to add the exponents. So let's try a couple. So if we have log base 3 of 2x, then we can break this up into log base 3 of 2 plus log base 3 of x. If we have log base 6 of p times q, we can separate those, so we can have log base 6 of p plus log base 6 of q. And then if we have the natural log of x times z, we can break that up into the natural log of x. And remember, natural log means log base e plus the natural log of z. Now, when we have a product, we can break it up with addition. So the inverse of that would be, if we have division, we can break it up using subtraction. So our first example, we're going to have log base 2 of 3 minus log base 2 of x. Now our next example is a little bit more complicated, because we have a pair of things being multiplied and we have one being divided. So we're going to say log base 6, and we can break up our product using addition. So log base 6 of x plus log base 6 of y minus log base 6 of z. Now, when we look at most of our calculators, we will find that we have two bases on our calculators. We have log base 10, often just called log, and we have ln, natural log, that's log base e. Well, what if we're looking at a problem like this? We have the log base 2 of 7. Well, that's a question that says, to what power must I raise 2 to make it equal 7? Well, I know that 2 to the second power is 4, and I know that 2 to the third power is 8. So I intuitively know that my answer lies somewhere between 2 and 3, but I'm not really sure. But I can put it in my calculator as long as I use the change of base formula. So let's use our change of base formula here. So we're going to say that we have log of 7 over the log of 2. If you'll put that in your calculator, any scientific calculator, that's going to give you the exact answer. Well, I mentioned that the other logarithm that most of your calculators are familiar with is the natural log, that is ln. Well, let's use ln. So if we have the ln of 17 divided by the ln of 3, we can also put that in our calculator. And we'll get an exact answer. So this is called the change of base formula. Now, one of the most powerful concepts in working with logarithms is the idea that if we have a value being raised to a power, if we take the logarithm of that value, then the power comes out front. So as you can see in our example here that we're going to take this n, the exponent, we're going to bring it out front. So let's take a look at a couple of examples. Well, if we bring this power out front, we're going to have n times log base 3 of x. And bringing this power out front, we're going to have x times the log of 6. Of course, that means log base 10. That doesn't mean log base 6. That's log base 10. So here's a summary. So logarithms are really exponents. Logarithms and exponents are inverse functions of each other. Therefore, they will cancel each other out. And logarithms are, of course, governed by the rules of exponents in reverse. So the rules of logs need to be memorized in order to be used as needed. Well, thank you for your attention, and stay tuned for another video where we're going to do some more complicated examples. Thank you very much.